Miguel Martinez, and I, Camila, will talk about some important properties of fluids in the subject of fluid mechanics.
In the study of fluid mechanics, understanding the properties of fluids is essential for predicting their behavior under different conditions. These properties define how fluids move, deform, transmit pressure, react to temperature, and interact with their environment. The properties of fluids can be classified into two groups, depending on their nature and application. Second, thermodynamic properties. These are related to the exchange of energy and the state of the fluid. Here we find pressure, temperature, specific heat, internal energy, enthalpy, and entropy. And finally, rheological or flow properties. These properties determine how the fluid responds when forced to flow. They include the type of fluids, Newtonian or non-Newtonian, and parameters such as the Reynolds number, which tell us whether the flow is laminar or turbulent. Next, we will discuss the most important properties in the study of fluids in the context of fluid mechanics, focused on civil engineering.
Now, I will talk about the most important ones in the study of fluids, which are density, temperature, pressure, Reynolds number, and viscosity. Density is a fundamental property of fluids that tells us how much mass is contained in a certain volume. It is useful for comparing different substances and predicting how they will behave under different conditions. And it is represented by the Greek letter rho, and the formula is rho equal mass volume. In international system, mass is measured in kilograms, kg, and volume in cubic meters, so density is expressed in kg per cubic meter. Viscosity is the property that measures how much a fluid resists flowing. This resistance is caused by internal forces between the fluid's molecules. The stronger the interaction between them, the higher the viscosity. They are two types: dynamic viscosity, which measures the internal resistance to motion, and kinematic viscosity, which relates viscosity to the fluid's density. Dynamic viscosity, also known as absolute viscosity, measures the internal resistance of a fluid when one layer moves over another. It is represented by the Greek letter mu, and its unit in the international system is the Pascal second. The formula is mu equal d/di, where d is the shear stress and d/di is the velocity gradient, meaning the change in velocity between fluid layers. Kinematic viscosity measures how a fluid flows under the influence of gravity, taking its density into account. It is represented by the Greek letter nu, and its formula is nu equal mu rho, where mu is the dynamic viscosity and rho is the fluid's density. And its unit in the international system is square meters per second. Pressure is a property that describes the force a fluid applies on a surface. One way to calculate it is with the formula P equal Fa, where F is the applied force and A is the area over which the force acts. It can also be calculated using P equal rho GH, which applies to fluids at rest. In this formula, rho is the fluid's density, G is the acceleration due to gravity, and H is the height or depth of the fluid. Pressure is measured in Pascal in the international system. Temperature is a property that indicates the thermal energy level of a fluid. As temperature increases, the fluid's molecules move faster. This affects other properties. For example, it usually decreases viscosity in liquid but increases it in gas. It can also affect density, since many fluids expand when heated, causing their density to decrease. Temperature also influences pressure, especially in confined gas. The Reynolds number is a value that helps predict the type of fluid flow, whether it will be laminar or turbulent. It is calculated with the formula R equals rho B D slash mu equals B D slash mu, where rho is density, B is the fluid's velocity, D is the pipe diameter, mu is dynamic viscosity, and nu is kinematic viscosity. If the Reynolds number is low below 2000, the flow is laminar. If it's high about 4000, the flow is turbulent.
Application exercise. A water flow at 25 degrees Celsius passes through a horizontal pipe with a diameter of 0.05 meters, a length of 1 meter, and an average velocity of 2 meters per second. The flow is in a situation where the pressure is not directly provided, but is needed to find it. In this exercise, we need to calculate first the kinematic viscosity of the water, second, the Reynolds number for the flow, and last, the pressure drop. To solve this exercise, we begin by calculating the kinematic viscosity. We apply the formula for kinematic viscosity, which tells you that kinematic viscosity equals dynamic viscosity divided by the fluid density. This gives us the kinematic viscosity in square meters per second, which will help us later for calculating the Reynolds number. Next, for Reynolds number calculation, we use the formula where the Reynolds number equals flow velocity times diameter divided the kinematic viscosity. We use calculate by substituting the given values. We will obtain a Reynolds number that allows us to classify the flow. In this case, we have a turbulent flow. Finally, to find the pressure drop, we use the Darcy-Weisbach formula for the pressure drop. For this, we first calculate the friction factor. For a turbulent flow and a pipe smooth, we can use the Blasius formula, which is only valid for a Reynolds number lower than between 10 raised to 5. Once the friction factor is obtained, we replace all the values in the pressure drop formula. This formula tells us that the pressure drop is equal to the friction factor multiplied the length over the diameter multiplied by the density by the speed to the square divided 2, resulting this difference in pascals. In this case, we are working in the international system of units. Conclusion. Mastering the properties of fluids is essential for applied fluid mechanics in civil engineering. Each properties provide critical information for solving designs, operation, and maintenance problems of hydraulic systems and fluid-related structures. Understanding density, viscosity, pressure, temperature, and Reynolds number allow us to predict and control the behavior of fluid in any system.
These properties are essential to understand how fluids behave in different situations. They allow us to analyze, design, and improve systems involving fluids, such as pipelines, engines, or even the human body. Thanks you for your attention, for watching. See you the next time. Goodbye.